Hello, my name is Tallulah Lutkin and I'm Utility Performance Editor at Global Water Intelligence. Back in March, I travelled to New York to the UN Water Conference. And for me and my colleagues at GWI, the most exciting thing to come out of the Water Conference was this little booklet. It was published by the Global Commission on the Economics of Water, and it's their call to action. It presents 7 action points that all stakeholders involved in water, which is pretty much the whole planet, need to be working towards in order to ensure that we have enough water for all and that we're managing that water sustainably. The full report will come out in a year and a half, but we at GWI consider this to be a game-changing approach to solving the water crisis in terms of governments, policy, finance, innovation. And this is why we wanted to give you some insights into this report to frame the discussion around water finance at the 2023 World Water Week. The principles in this call to action and those that are framing the upcoming report are grounded in scientific research and are driving innovation in finance in the water sector. So for this, I spoke to 3 of the co-chairs of the Global Commission of the Economics of Water, as well as one of the commissioners, who each bring their perspective to this collaborative effort by the Commission. And I hope you find it insightful.
This is one of the, let's say, fundamental scientific entry points for the economics of water work, which is that we have so much evidence today that we are, as humanity, posing so large pressures on the Earth system as a whole that we are changing the functioning of the global hydrological cycle. So for the first time, we have to recognize that not only, which we have known for a very long time, that we're changing the water supply and having rising water demands and water quality challenges and how water flows in river basins and watersheds. But now also for the first time, we have to recognize that we're changing the very input, namely precipitation levels, through climate change, but also through land use change. So today we cannot even rely on rainy seasons or influxes of fresh water at any scale, at any time step. We're also seeing more and more evidence that water that we often perceive as a local issue is in fact much more regional and much more interdependent across different geographical scales, because it's not as simple as we've often portrayed it, that the precipitation over land originates from evaporation from the oceans, but that in the order of 40, in some places up to 50% of precipitation levels comes from green water flows, meaning evapotranspiration flows from ecosystems, from land areas. And this is fundamental because it means that upwind countries with large forest systems often generate and export water, supplying and securing precipitation levels for downwind countries. So you have atmospheric rivers that are flowing in the atmosphere, just like we have rivers on land, which goes from upstream to downstream, but in this case is upwind to downwind, and securing or at least influencing water supply across big regions. And this science, these two kind of conclusions from the science, that one, we are for the first time jeopardizing or threatening the very supply of precipitation, where we're shifting the global hydrological cycle. And number 2, that we have these atmospheric rivers where what happens upwind on land influences the availability of water downstream. Take these together and we draw the conclusion that we have to define and understand and manage and value water as a global common good, meaning that we can no longer think of water being something that is provided by the environment beyond any influence by humans, some gift from God, which then has variability and challenges, but just natural variabilities, and then that our human challenge only being allocation of those resources and ensuring efficient water use and water quality. we're arguing that that is not enough. The new economics of water must also be stewards of the very source, ensuring the stability of the whole planet, ensuring the stability of the hydrological cycle, and recognizing these atmospheric rivers. And the implications of this is very dramatic, because you have, just to give you a few examples, that a country like Russia, for example, is a massive importer of precipitation. So depending on green water flows from forest systems from neighboring countries to the west. So countries like Ukraine and Kazakhstan and the Baltic states and the Nordic states. So you have a downwind country, Russia, depending on management of ecosystems upwind. And then you have countries like Brazil, that is hosting a major precipitation provider and supplying that downwind to countries in the southern parts of South America. So a big exporter of fresh water. And this is not only a major issue in terms of geopolitics, but it's also an issue of how you value fresh water as a capital asset in terms of the stability of economies, because we know that if you push water beyond thresholds in terms of extremes, I mean, both flooding and droughts, you impact on food, on energy, on basic livelihoods, which then can translate into impacts on economy, but also in social instabilities. So that is basically the let's say the scientific journey from the basic science on global hydrology, atmospheric rivers, and earth system pressures, all the way to concluding water as a global commons, and how that then impacts on valuation of fresh water.
And I also had this term that I think that you have used, this term of planetary boundaries, and that you have said that we are kind of outside of the safe zone when it comes to fresh water in terms of those planetary boundaries. And sort of, how is that linked to these atmospheric rivers, and what does that actually mean in practice, that we're kind of outside of the safe zone, and why is that dangerous?
The reason why we are at this juncture where we're now at risk of changing the inflow of fresh water. So we are, through climate change, powering up the whole hydrological cycle by adding even more vapor to the atmosphere, because the warmer the temperature on Earth, the more moisture can be held in the atmosphere and more evaporation occurs from the ocean. But also when we transgress the planetary boundaries on biodiversity, on land system change in particular, we change the green water flows, the green water being, the part of the hydrological cycle where rainfall infiltrates in the ground, and a significant portion, actually 70% of the fresh water flows back into the atmosphere as transpiration was taken up by roots and evaporation from soil and land surfaces. Now, this occurs because we're transgressing planetary boundaries. So the planetary boundaries are defined to provide us with a safe operating space that keeps the Earth system in a stable state in terms of all the life support systems. So basically, it's about setting scientifically defined boundaries that can keep the planet as close as possible to the Holocene state that we've had, for 12,000 years of civilizational development before we started this exponential rise of pressures on the planet through unsustainable, exploitation, both of fresh water, but also of all the other boundaries. So the boundaries are set to keep the hydrological cycle within a safe space. And we've identified 9 large systems and processes that together regulates the state of the planet, and climate being one, the global hydrological cycle being a second, so the bloodstream of the whole Earth system. But then we also have what I call the biosphere boundaries, which is land system change, biodiversity, the interference with the 2 big nutrient cycles, nitrogen and phosphorus, And these together, so water, land, biodiversity, nutrients forming the biosphere boundaries. And then, of course, you have chemical loading, which influences water quality, stratospheric ozone depletion, the protective stratospheric ozone layer, aerosol loading, so air pollutants, which also affects freshwater supply, because when you dim the lower atmosphere too much with smog and particles like black carbon and sulfates causing reflection of incoming solar radiation, it changes the energy balance and impacts also on monsoon systems, so also impacting our freshwater supply. And finally, ocean stability. So the boundaries are set to keep the hydrological cycle stable, and now we are outside of the safe space, not only on the water boundaries, but also on the biosphere and climate boundary, which all of these together impact back on the hydrological cycle. So you deforest too much and change too much of terrestrial ecosystems, it impacts on green water flows. You transgress the climate boundary, you change the energy balance on planet Earth. You change the aerosol boundary, you get more pollutants, you impact on the monsoon. But moreover, we today must conclude, based on the latest science, that we are transgressing not only the boundaries that impact on the supply of fresh water, so all the other boundaries, the biosphere and the climate and the air pollution boundaries, but we're also transgressing the water boundaries themselves. What this tells us in conclusion is that we're both losing the resilience of the Earth system's capacity to keep the hydrological cycle stable, and moreover, we are mismanaging the cycle and pushing the boundaries outside of their safe levels. So that is also very strong scientific arguments why we need to very rapidly come back within a safe space to keep the hydrological cycle or the water balances across river basins on Earth within a manageable range.
And how much of this is due to, obviously these are both kind of human-induced, but how much is due to climate change and how much is due to the other things that you mentioned? So things like land use, deforestation, agricultural choices. Which one of those impacts the water cycle more, or is it both? Or where does the work need to be?
That's a really good question, and it doesn't have a straight answer because it varies depending on what location you are at. I mean, if you take, let's say, an aggregate view on the planet as a whole, I would argue that climate change is the dominant driver of change of causing extremes in terms or extreme variability in terms of freshwater supply. So droughts, floods, heat waves, which also evaporates water and thereby induces more water scarcity. This is, let's say, if you look at it unified across the entire planet, I think climate change is the dominant force. However, when you look at specific areas, like for example in the rainforest regions, then it's clear that land use change is an even more important driver right now. I mean, so deforestation, drying out the systems and reducing green water flows and thereby convective rainfall. So if you lose the broad canopy cover in moist, very, very humid rainforest systems, they get opened up, they get dried out through air flowing through. It reduces the whole cycling of vapor and thereby reduces precipitation levels. And this moisture recycling is due to land use change and of course reinforced by climate change. But there you have a combination of both. And then finally you have what you could argue being one of the biggest concerns right now from a local perspective, which is the glacial melt, when mountain glaciers, which are mountain fountains of freshwater supply, and of course the big ground zero here is the Tibetan highlands, with feeding 7 big rivers. I mean, massive rivers like the Ganges and the Mekong, which then supplies fresh water for billions of people across South and Southeast Asia. So you cannot really single out climate change or land use changes. It's often combinations, and it differs from location to location.
And so all these changes that are happening, or this urgency that we have to fix the problem, what does that mean for the way that we are going to value water? And, what are the investments that are needed sort of now, and where are the priorities for making those changes?
Yeah, so that's the big question, how to economically value water. And the starting point is very dire, because we are mismanaging. Not only are we mismanaging water, both in terms of quality and quantity, we're not even able to supply fresh water for, the 3 billion people across the world that are lacking access to adequate, healthy fresh water levels just for domestic water use. And we have an even larger challenge when it comes to securing fresh water for food in the future. So this is a strong proof that we're undervaluing water. We're simply taking water for granted as a free public good, when in fact it is a very precious finite resource that we are at risk of that is at risk of being one of, if not the factor that hinders us from delivering on the sustainable development goals of eradicating poverty and hunger, and certainly will be a very determining factor when it comes to whether or not we'll be able to deliver on the climate and biodiversity frameworks, because fresh water is behind all carbon and fresh water is behind all life. So we're undervaluing water, and we're working very hard in the Economics of Water Commission to think through what are the economic policies that we would recommend to be put in place to put an economic value on water when it comes to investments. And this is very difficult. It has been tried for decades. I mean, there's been since the Dublin Conference 1992 and the World Water Forum work in the Netherlands in the millennium on putting a price on water and valuing water as an economic good. The recognition that is very complicated, because you stumble into major institutional challenges, but also equity challenges. It's not as simple as just putting a dollar sign on water and you've solved the problems, because water is a fundamental human right. It's even recognized in the UN Charter as a fundamental human right. So I think that the path forward is not to put a monetary value on water. Of course, there is a monetary value on water when it comes to treated water in urban areas for drinking water supply, for example. I mean, we can have much better efficiencies through conventional economics for domestic water in cities, no doubt. But it's much more difficult to put a monetary value or put water in economics for the big volumes of water, which is for food, for ecosystems, and for societal stability. And for that, I mean, just to a little tangent to remind us that, for domestic use, we need, something like 50 to 100 liters of fresh water per person per day. But we need something like 3,000 liters per person per day for food. So the big fresh water, supply required for human well-being is for food, 95%. Domestic use, industrial use, for health are very important, fundamental for water quality, but they're not quantity challenges. We will never run out of water for drinking water, ever. But we may be running out of water for food and for ecosystems, for energy and biomass. That's the big consumer. So how to put an economic value to that? And that's where we are today working, that there's a very big difference between monetary value and economic value. You can put a value, economic value on water as a capital asset without necessarily putting a monetary value on it, by quantifying water as a currency behind different services that society needs to or wants to provide for its citizens. So, for example, if you have a country or region that wants to secure healthy diets for all its citizens, you can quantify how much fresh water is required to deliver that, whether it comes locally or from virtual water from trade. And if you induce or introduce economic policies that really invests in that, then of course the investments are the monetary costs to secure the drip irrigation systems, the dams, water harvesting system, whatever management systems you put in place. But the monetary value is not on per cubic meter water, it's rather on the infrastructure you put in place to secure that service, which is your per capita minimum amount of fresh water for human well-being. So this is ongoing work, and we're hoping to make some major advancements here. But I come back to the where I started. The new concept is water as a global commons. That if you are Brazil and you are hosting a significant part of the Amazon basin, you're hosting and being steward of a global commons. And that commons is a producer of rainfall, and it's an exporter of fresh water. So if you're hosting a global commons, which is a service to humanity, and particularly a service to your downwind neighbor countries, you should be in a position to be compensated for that, economically compensated for that. And I think that is also an additional economic policy dimension of the economics of water.